Okay, we have here area between graphs. This is an example or the application of integral calculus wherein we're going to find the area of the region that is bounded by two or within the two graphs. Okay, so we have our problem. Find the area of the region bounded by the graphs of y squared equals 1 minus x and 2y equals x plus 2. Now, in order to solve this problem, we have to draw the graph in order to visualize the problem. Okay? Now, this graph involves two equations, y squared equals 1 minus x and 2y equals x plus 2. Now, this graph, y squared equals 1 minus x, this is an equation of a parabola which is linear in x. Okay, if we speak of linear, it means that the exponent of x is 1. Try to look at the exponent of y, which is 2. So, this is not linear, but in x, it is linear in x. Because the equation of x, the exponent of x equals 1. Okay, so in other words, this parabola is linear in x, and the opening of the parabola is, if that is linear in x and x equals negative, therefore the parabola is opening to the negative x. Okay, and then this one, 2y equals x plus 2, this is the equation of a line. Now again, we're going to draw the graph. Okay, so we have this one, so we have y squared equals 1 minus x. This is the equation of a parabola. So, rewriting this one, y squared equals negative x, we have this one, and then positive 1 plus 1. And again, y squared equals negative of x minus 1. In other words, if you multiply negative times x, you have here negative x, and then negative times negative 1 equals positive 1. Okay, I am just rewriting this one. Okay, now why I am rewriting this equation into this equation? Because we have our general equation of a parabola. Y minus k squared equals negative x minus h. Okay, that is why I have here y raised to 2 equals negative of x minus 1. Okay, now from our general equation of a parabola, our k is, from this one, y supposed to be y minus something, but there is no equivalent, so I am writing here as y minus 0. Okay, in other words, the value of k is equal to 0, which is equivalent to negative x minus 1. We have here negative x minus 1. In other words, our h is equal to 1. Okay, since the vertex is located at hk, then our h again is 1, x minus h, so our h equals 1, and then y minus k, our k is equal to 0. We have this one. Okay, so the vertex is located at x equals 1, y equals 0, so this is now the points. X equals 1, y equals 0, so we have this one. X equals 1, y is equal to 0. So this is the vertex of a parabola. Okay, again, it is opening to the negative x, because this, our equation is negative x, linear in x, linear in x, and then this is negative, so opening to the negative x. Okay, so after we draw the parabola, we have here a line. How do we draw our line? Okay, so this is an equation of a line. 2y equals x plus 2. Okay, now assume the value of x as 0 initially, or we have an assumption. If x equals 0, then from this equation of a line, substitute the value of x as 0. So 2y equals 0 plus 2 equals 2. So that 2y equals 2, y equals 2 over 2 equals 1. Okay, so you have here y equals 1. Okay, now if we assume, if we assume the value of x as 2, then substitute the value of x as 2 from the equation of a line. So 2y equals 2 plus 2, which is equivalent 4. 4 divided by 2 equals 2. Therefore, y equals 2. We have this one. Okay. Then next, if we assume the value of x as negative 8, for this case, I am assuming the value of x as negative 8, then negative 8 plus 2 equals negative 6 divided by 2 equals negative 3. That is the value of our y. Okay, so if we draw x when x equals 0 and y equals 1, if x equals 0 and y equals 1, then this is the point. Okay, x equals 0, y equals 1. We have this point. Now, from this one, if x equals 2, y equals 2. So if x equals 2, y equals 1, 2. This is your 1, 2. So this is now the point. So if we connect these 2 points, we have here 2, 2, and then 0, 1. So we have this line. And then next, if I assume the value of x as negative 8, then the value of y equals negative 3. So if x equals negative 8, the value of y equals negative 3. 1, 2, 3. If x equals negative 8, the value of y is negative 3. So this is now the point. Connecting these points, this point and then this point and then this point, that is now my equation of a line. Okay? So we have this graph, we have this parabola, we have this line. Now, how are we going to determine the intersection between this line and the parabola? Okay, so we have this one. By combining the two equations. Okay, so we have y squared equals 1 minus x, and then y squared equals 1 minus, instead of writing x, I am substituting the value of x as 2y minus 2. This 2y minus 2 is coming from the equation of a line. Remember, our equation of line equals 2y equals x plus 2. So 2y, our 2 will be transferred to the other side. That becomes negative 2. Okay, and then equals x. In other words, the value of x is 2y minus 2. I am using this x to our equation of the parabola. In other words, I am now combining the two equation of line and equation of parabola. Okay, so that is 2y minus 2. So that y squared equals 1 minus multiplying negative 2 positive 2y, that is negative 2y, and then negative times negative 2 is positive 2. Okay, and then 1 plus 2 is equivalent to 3, and then this is negative 2y. So y squared equals 3 minus 2y. By rewriting this one, y squared, we have this one, and then negative 2y will be transferred to the other side. That becomes positive 2y. So we have here, and then 3 to the other side, this is positive 3, transferred to the other side, that becomes negative 3. So we have here negative 3, which is equivalent to 0. And then by factoring or using your calculator, okay, quadratic equation, you can find the value of y. So for this case, I am doing a factoring. So this is negative 3, so I must have a factor of positive 3 times negative 1, that becomes negative 3. And then if I will check 3 plus negative 1, that becomes positive 2. So this will be my factor. Okay, so y plus 3 is equal to 0, and then y minus 1 is equal to 0. So that y plus 3 equals 0 is equal to y sub 1. I am using this sub 1 as first value of y. Y equals, when 3 transferred to the other side, that becomes negative 3. On the other hand, y minus 1 equals 0, and then negative 1 to the other side, that becomes positive 1. So this is my other value of y. So I am using y sub 2, I am using y sub 1 for different values of y. Okay, now from the equation of a line, we have this one. So actually I can use this one or this one. Since I have the value of y sub 1, y sub 2, I want to find the value of x sub 1, x sub 2. So I am using equation of a line. X equals 2y minus 2. We have this one. 2y minus 2. If my y sub 1 equals negative 3, substituting this negative 3 to our equation of a line, then I can have here x sub 1 equals 2 instead of y, that is negative 3. 2 times negative 3 equals negative 6 minus 2 equals negative 8. And if my y sub 2 equals 1, this is the other value of y, then substitute the value of 1 to my equation of a line. X sub 2 equals 2 times 1. Instead of writing y, I am using 1 2 times 1, 2 minus 2, that is equivalent to 0. So in other words, I have here x sub 1 equals negative 8 and x sub 2 is equivalent to 0. Therefore, the points of intersection, my y sub 1 equals negative 3 and x sub 1 equals negative 8. We have here negative 8, negative 3. My x sub 1 equals negative 8. And then another points of intersection is my x sub 2 equals 0, y sub 2 equals 1, 0, 1. So these are the points of intersection between the graphs of a parabola and a line. Okay, that is why from our drawing, remember p sub 1 negative 8 and negative 3, p sub 2 equals 0, 1. So we have this drawing. Okay, we have this drawing. Okay, negative 8 and negative 3 and then 0, 1. Okay, these are our intersections of the two graphs. Okay, so after we draw this graph, of course I will draw it again in our board. We have here. Okay, so I will draw it again, and then we have here 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, and then I have here 1, 2. So 8 and then 3. You have here 8 and then 3. Okay, so I am now drawing the parabola. Okay. Okay, that is now our parabola, which is I am rewriting here as x, which is equivalent to, transferring this one to the other side, that becomes 1 minus y squared, the equation of a parabola. X equals 1 minus y squared, or you can write this one, y squared equals 1 minus x. You can write that one. Okay, now the other one, we have here a line. This is the intersection. We'll draw a line. Okay, this is a line. Sorry for my line. Okay, okay, it's supposed to be a straight line. Okay, now this line, we have here 2y equals x minus x plus 2, or x is equivalent to 2y minus 2. Okay, 2y minus 2. That is the equation of a parabola. I mean a line. Equation of a line. Now, after this one, we have our intersection at x equals 0, y equals 1, x equals 0, y equals 1. Then this one, x equals negative 8, negative 3. Okay, x negative 3. Now after we draw the graph of the two function, that is your parabola and then the line, of course, going back to the problem, find the area of the region bounded by the graph. So the region that is bounded by the graphs of parabola and line, we have here a line, and then our parabola is this region. Okay, these are the region, or this is the region that is bounded by the two graphs. Now, in calculus, we're going to apply or use, to solve the area, we can make use of the vertical strip. We have this one, or horizontal strip. We have this one. Horizontal strip and vertical strip. Now, in my case, I will be using horizontal strip to solve this problem. Okay, so horizontal strip. So using horizontal strip, this point will be my XR or X right, and then this point will be my XL or X left. Okay, XR stands for the value of X from the right of this horizontal strip, and XL is the value of X on the left of this horizontal strip. That is my XR, XL. So that when we find the area, is equivalent to the integral of x dy, or the integral of, instead of writing x, I am using xr minus xl dy. Okay? Now, how about the limits? Take note, that is dy. So, if that is dy, we will base our limits to y. So, we have this one, we have this one. Y. This is x, this is y. So, x, y. Okay? Now, take note also that this region is within this one. 1, 2, 3, and then 1. Okay? The value of x, I mean y, the minimum, the limits, lower limits is -3. And then the upper limits wherein the region is located is at +1. This is +1. Okay? -3, the value of y is -3. And then the value of y is +1. This is the limits, lower limits and then upper limits wherein the area is located. The area of the region is located. Okay? Now, we're going to write the lower limit, which is from -3 and then +1. This is based on the value of y. Okay? Which is -3 and -1. So that when we solve the area, we have here -3 and then +1. Now, how about our xr? This xr is the x value of a graph passing to this point. So, what is the graph that passed through this point? This is a parabola. The x value of the parabola. So, the x value of parabola is equivalent to 1 minus y squared. See, this is the equation of a parabola. So, we have here 1 minus y squared. That is now my xr. Okay? And then, our xl is the x value of the graph that passed through this point. So, the x value of the graph that passed through this point is the line wherein x is equal to 2y minus 2. So, we have here 2y minus 2 dy. So, we have here the integral of the lower limit is -3, upper limit is 1. 1 negative times -2 is +2 plus 1 equals +3 minus y squared. We have this one, and then negative times 2y equals -2y. Okay? dy. Using your calculator, we can find the area which is equivalent to find the area that is equivalent to area is equivalent to 32/3. So 32/3 square units. Okay? So that is now the area of the region that is bounded by the graphs of this parabola and then this line. So the area equals 32/3 square units.